Welcome back to the channel. If you have ever tried doing complex calculations in ladder logic, you know it can get messy fast. Multiple networks, lots of intermediate tags. And if you need to make a change later, it's a headache. In this video, I'm going to show you why SCL, or a structured control language, is a better choice for calculations in TIA Portal. We'll take a real-world engineering formula and see how ladder logic needs multiple steps to do it, but in SCL it takes just one clean line. Let's get started. Okay, the example we'll use is a flow rate calculation based on differential pressure. This is something you'll often see in process automation. Here is a formula on the screen. As you can see, Q is the flow rate in cubic meters per hour. K is a constant, delta P is the differential pressure in pascals, rho is the fluid density in kilograms per cubic meter. In this lesson, we'll build a real calculation properly. First, we'll create a parameters data block, then implement the formula in ladder step by step, and finally replace all that with one SCL line. Okay. On the project tree, let's create a new data block. Let's name it parameters. Beautiful. Let's create our tags. We have delta P, of course, real. We have density, same data type. We have the constant K and our flow rate. And let me name it QLAD, which is indication for the ladder logic. Okay, let me make it smaller. Let's have it on the screen. There we go. Beautiful. Okay, let me make it a bit bigger. Let's name it flow rate calculation. All right. In network 1, let's divide delta P by density and store it in an intermediate tag. Here is the delta P, we need also density. Let's save the result in an intermediate tag named temp1. Okay, let's take the square root of temp1 and store it in temp2. All right. Now we need to have another block to multiply temp2 by K. Finally, let's have our output here. All right, here is our formula in ladder logic. Okay, let's save the project and let's do the SCL block. I create a new function, I name it like this, and the language should be on SCL. Perfect. Here is our function. Let me make it a bit bigger. Now in the block interface tab, we'll define our inputs and outputs. For this calculation, we'll have three inputs: delta P, density, and our constant, all of course real, and the output is Q, and that is also real. Okay, now let's write our formula in SCL. Q. We basically assign the result of the calculation to Q. Here is our constant multiplied by square root of differential pressure over density. There we go. That's it. So simple. Let's save the project and go back to OB1. I'll compile the project again. Yes, we need to compile our data block. All right. Now let's drag and drop our function in network 2. We don't need network 3. Let's delete that. Okay, now let's assign the inputs. Here is delta P, here is density, and our constant. Let me create another output, Q SCL. I need that to compare the result. Okay, there we go. Now let's assign test constants, delta P 2500, density 1000, and K 1.2. Okay, let's compile one more time. So let's save the project and oops. Right, we need to compile our function. Just go back here. No error. Beautiful. All right. Let's download to the PLC. Let's go online. All green, beautiful. Let's monitor the values. As you can see, both show exactly the same number. We had 3 blocks and 2 intermediate tags in ladder for something we wrote in just one line in SCL. Which one do you think is faster to write and easier to maintain? There is another advantage of SCL. If you need to modify the calculation, it's so simple. Let's say we want to add a temperature compensation factor into the equation. In ladder, you would need to add more blocks and tags. In SCL, we just update our single line. Let me go offline. Let me add another tag here. Let's name it temp factor. Temp factor. The data type is real, and let's say it's equal 1.4. Okay, in ladder we need to add another block like that. Let me move the output. We need to have another tag. Let's name it temp3. We need to multiply that by temp factor. Okay, now let's modify our SCL function. We need to have another input. Let's name it temp factor. All right, so it's so simple here. Multiply by, oops, there we go. All right, let's compile, no error. Okay, so let's come back here. We need to update our function block. Yes, all right, it's updated. We just need to assign the input. Beautiful. It's time to save the project and download to the PLC. There we go. Let's monitor the value. All right, as you can see, they are showing exactly the same number. But it was much easier in SCL. Okay, for anything calculation heavy, like flow rates, energy usage, scaling analog signals, motion control profile, SCL is simply faster and cleaner than ladder FBD. You can write formulas exactly as they appear in documentation, and you avoid the extra blocks, extra networks, and variables. In this video, you saw how a formula that takes multiple ladder networks can be written in one SCL line. In the next video, we'll look at all the basic math operators and functions in SCL. So basically, you will have a complete toolkit for any calculations you need. Thanks for watching, and don't forget to subscribe so you don't miss the rest of the series. Thank you.